Okay guys, so chapter 8, we kind of throw in a couple sections with chapter 7 because they really go hand in hand. Chapter 8 focuses on using matrices to help us solve systems of equations, okay? And so what happens is we would have something of a system of equations that maybe looks like this. Okay, and if you're not sure where I'm getting these numbers, if you look at the example we're about to do, these are the coefficients of my variables, and these are the numbers on the other side of the equals. Okay, so the matrix and the system are directly related because we keep everything lined up, all the x's, all the y's, all the z's, and we just write the coefficients in a matrix. Okay, so this is called an augmented matrix. Okay, and what this is a notation for row operations, meaning maths that we do with different rows. So this notation says take -7, multiply it by row 1, and add that to row 2. Okay, so we would take -7 times row 1. Let me write down this matrix here. Hold on one second. Okay, so this way we have it. So we're going to take row 1 and we're going to multiply it by -7. And we're going to add it to row 2. So row 1 times -7 would be -7, -21, positive 14. Lord, I need more coffee. And positive 49. So we're going to take this and we're going to add it to row 2, and we rewrite the new matrix. So the other two rows don't change. When we add this to row 2 is going to be the only row that's changing. So I go ahead and I usually just write down the other rows so I don't mess anything up. So now I'm going to take -7 times row 1, which is this, and I'm going to add it to row 2. So -7 plus 7 is 0. -21 plus 7 is -14. 14 plus 7 is 21. 49 plus 7 is 56. So the resulting matrix uses those values. Let me type this in real quick. And then we're going to talk about why we would want to do this and what this is helping. Okay. All right. So that's row operations. There's lots of different ones. We can add rows. We can multiply them by fractions or multiply them by constants, whatever. What is the point? What is this doing? Well, this is kind of the equivalent of solving systems by hand, but we're doing it without all the variables getting in the way, right? We're simplifying it a little bit by taking out all those variables. And so what we would end up doing, let me get a new screen here. Okay, what we would end up doing is, say we wanted to solve this system, and it will walk you through a process of doing row operations by hand, okay? And doing the row operations by hand, the goal is going to be, hold on, I messed myself up. There we go. the goal is going to be to get a matrix that has ones on the diagonal and zeros on the lower diagonal. And the rest would all be filled in with numbers, okay? And the reason we would do that is because then we would be able to see, okay, 1z equals this number, right? And we'd be able to work backwards. And that's what the view and example is going to do. But what I want to show you is how to get your calculator to do this for you, okay? Because this is very time consuming and you have time limits on your tests. I want you to be able to see what your calculator can help you with. So the first thing is we need the augmented matrix. Okay, and in that augmented matrix, we've got 1, 3, negative 1, 1, negative 1, 3, negative 1, 1, negative 2, and negative 2, 6, and 1. Okay, and you would go through by hand and you would rework this with row operations until you got something with ones on the diagonal and zeros underneath. Okay, but we can get our calculator to do that. And our calculator can actually do it better. Our calculator is going to put zeros here as well. And so then all we're going to have are numbers here. So our calculator is going to do all the row operations for us so that we're left with this matrix. Okay? So in your calculator, we do second matrix right here. This is a list of all our matrices. If we go over to edit, it's the same list, but now we can edit the matrix. So I'm going to just put in matrix A. Our matrix is going to be 3 rows by 4 columns. So then it sets you up, and we just need to type it in. So 1, 1, negative 1, negative 2, 3, 1, 1, 6, negative 1, 3, negative 2, and 1. Okay? And then you got to quit out of that. It's really important that you quit back to the main screen. Then we're going to go back into the matrix options, but we're going to do some math with our matrices. And we're going to scroll down, and we want RREF. If we do REF, that's row-echelon form. That means ones on the diagonal and zeros in the bottom half. If we do RREF, that's reduced row-echelon form. That puts ones on the diagonal and zeros on the bottom and zeros on the top, which is more simplified for us. That's better for us. So we're going to choose RREF. And we're going to choose matrix again. And now you see matrix A has something typed in there. It's a 3 by 4 matrix. So we want the reduced row echelon form of matrix A. And what the calculator's done is all the row operations needed to get this matrix to be this matrix. So it has ones on the diagonal, zeros in the corners, and then constants over here. So what does this mean? Well, what would this mean if we put the variables back in, right? This is X, this is Y, this is Z, right? X, Y, Z, X, Y, Z, right? If we put those variables back in and look at it for a second, my first equation is 1x plus 0y plus 0z equals 1. And 0x plus 1y plus 0z equals 8. And 0x plus 0y plus 1z equals 11. So we magically have these answers because the calculator did all the row operations for us, right? These row operations that we were talking about, we would be using these to get ones on the diagonal and zeros everywhere else. So like this problem, when we did a row operation, that accomplished getting us a 0 right here. That was why we would do that operation. So we would have to keep going. We would have to do at least 3 or 4 more row operations to get ones on the diagonal and zeros everywhere else, right? We'd have to do a lot of work. So what the calculator has programmed into it are these settings that do the row operations for us. And there's lots that you can do with matrices. We're not going to be getting into all that. The only ones we're going to be using are the RREF. Okay, so RREF automatically puts the matrix into this form so that our answers are going down the side. Does that make sense? Hopefully. If you run into issues with your calculator or questions about how to work anything, let me know. I can definitely help you. YouTube also has a lot of videos on how to work with the calculators. But it's going to save you a ton of time if you can use your calculator for some of these and not have to work them all out by hand. Okay? So, again, that's RREF, and it takes your matrix and it puts it in this format so that you can get your answers. Okay? All right, if you have any questions, please let me know.